Okay, let's look at exam 3B, problem number 10, part A. Right, let's evaluate this indefinite integral. Right, so first we're going to try to simplify using a substitution. So we're going to let u be the expression inside the square root. Right, so we're going to say let u be x squared plus 5. Right, and take the derivative of u with respect to x, which is going to be 2x, right? Derivative of 5 is 0. And take the reciprocal of both sides. We have dx over du, which is equal to 1 over 2x, right? Then multiply through by du. We can get dx is equal to du over 2x, right? So let's rewrite this integral. So you have integral sign, right? I'm going to leave 2x as it is, right? Then we decided to call x squared plus 5 u, so you have a square root of u. So we took care of this, and we took care of that, and there's a dx. But dx, we found out that it's the same thing as du over 2x, right? And there's 2x on top and 2x on the bottom, cancel out. So what you get is integral, right? I don't like square roots, so I'm going to rewrite it as u to the 1/2 power. Then there's du, right? Then take the antiderivative, so you have u, add 1 to the power. 1/2 plus 1 is 3/2. Right, divided by 3/2 is equivalent to multiply by 2/3, right? Then plus some constant c, right? And after that, you just need to plug in original expression here. So instead of u, so answer is 2/3, just a constant, and c is quantity x squared plus 5, raise it to the 3/2 power, plus some constant c, right? So this is the answer for part A. Right, let's look at part B. Part B is very similar. We wish to have a single variable up here, so we're going to call that guy u. So let u be x to the 4th power, right? Then take the derivative of u with respect to x. You get 4x cubed, right? Then take the reciprocal of both sides. You have dx over du is equal to 1 over 4x cubed, right? Then we can multiply through by du. So we have a dx is equal to du over 4x cubed, right? So let's rewrite this integral, right? So we have an integral. And I'm going to leave x cubed as it is for now, right? Then you have e to the u. And dx is the same thing as du over 4x cubed. So du over 4x cubed, right? So you can cancel x cubed and x cubed, right? Then this is going to be equal to, right? 4 is on the bottom, which means that the 1/4 is a constant. Then you have an integral sign. Then there's e to the u here. And then you have a du, so du there. Right? Antiderivative of e to the u is kind of nice because that's just itself, e to the u, plus some constant c, right? Then we can just plug the x to the 4th back in for u. So it's going to be 1/4 e to the x to the 4th plus some constant c, right? So this is the answer for part B, right? Let's look at part C. I'm going to slide down a bit so that we have a little bit more room, right? All right, we want to evaluate this definite integral, all right? So we have, let's see, there's a natural log of x there. So we're going to call that guy u, right? So let u be natural log of x, right? Then take the derivative of u with respect to x as usual, which is 1 over x, right? Take the reciprocal of both sides. We have dx over du, which is x, right? Then multiply through by du, which is going to give you dx equals x times du, right? So and also we need to convert the x values here. So we know that let's see, x goes from 1 to e, so it's going to go from 1 to e, right? Which means that the u is going to go from, right? We just need to plug 1 into the substitution equation. Natural log of 1 is 0, so u starts from 0, and natural log of e is 1, right? So this integral is going to become integral from 0 to 1, and natural log of x, we decided to call that guy u, right? I'm going to leave x as it is, right? Dx, we just found that it's same thing as x du. So you have x du, right? So you can cancel x's like that, right? So clean it up. So it's an integral from 0 to 1 and u and a du, right? So this is an easy integration, fundamental theorem of calculus. Antiderivative is u squared over 2, and then you have to go from 1 to 0, 0 to 1, right? Right, plugging 1, it's going to be 1 over 2, minus plugging 0, it's 0. So that's going to be 1/2. Right? So this is the answer for part C. All right, that's it. I hope that this was clear.